This video segment is devoted to the next instructional activity in the sequence, one we call Candy Flash. Most teachers love this activity. As they use it repeatedly, they can see how children advance in the way they reason and how Candy Flash contributes to their understanding of coordinating units. This activity will be used productively for many weeks, including in combination with activities from part 2 of the sequence. Before going further, let me describe the flashing approach for those that are not yet familiar with it. It is an approach we use with many of our activities. The teacher displays something, in this case, a configuration of roles and pieces, for a few seconds, hides the display for several seconds, shows the display again for several seconds, hides again for several seconds, and repeats the process up to 3 or sometimes 4 times. Before I can show you an example, I have to explain that in the pictures I will show you, a role looks like this, and a piece looks like this. And of course, we have to explain that to our students initially as well. In our experience, it is important to use a few introductory examples to ensure that children understand the intention of the task. Let's walk through how that might be done. After establishing what a role and what a piece of candy will look like, we might use this as our first task. These are the candies Mrs. Wright has. Flash this image 3 or 4 times as described earlier and ask the students, how many candies does Mrs. Wright have? Leave the image off as children give their answers and turn the image on again as the discussion proceeds so children can make sense of what others say. Now, the purpose of this task is to establish what we mean by the question, how many candies does Mrs. Wright have? The answer is 34. In other words, we are not asking students to report that there are 3 roles and 4 pieces. We are asking about the total quantity. Children have to recognize which items represent roles, units of 10, and which represent pieces, units of 1. And they have to be able to use those 2 different types of units to figure out the quantity, to figure out that if you put 3 10s together with 4 1s, you get 34. This task is easy for someone that already knows that 3 10s together with 4 1s is 34. But children that do not just know that have to figure it out somehow. How might they do that? One way we often see is that they count. For example, they might begin counting at the left, 10, 20, 30, and continue on as they move to the pieces on the right. Now, in most classrooms, there will be 1 or 2 children that come up with 70 candies. What's happening here? Such children started counting by 10s, 10, 20, 30, and then they continued on by 10s, 40, 50, 60, 70 as they counted the pieces. These children are unable to make a shift in the midst of their counting activity from counting by 10s to counting by 1s. For some of these children, their counting activity is entirely rote. It has nothing to do with quantity. It is more like reciting a poem. So after they begin saying 10, 20, 30, they continue on with the 10s poem. Teachers that have not used this approach to coordinating units previously might think that I'm making this up. No one would say that there are 70 candies here, but I can guarantee you that I have often seen children do exactly that. Other children will disagree with 70 and say, how did you get 70? And a lively discussion will ensue. In the discussion, children will explain to each other ways they got the answer of 34 and why 70 is not correct. Class discussions like this are important because it is through the discussions that children have to justify their answers to others in the class. And as they hear others' responses to what they say, they have the opportunity to advance in their understanding. Here's a task we might use next. Again, the image is flashed 3 or 4 times and children are asked how many candies Mrs. Wright has. And again, the image is left off as the children begin to give their answers. As the discussion progresses, it is important for the image to be visible again so students can refer to it. As with the previous task, some children will find this one easy, but others will count. And this time, some will answer that there are 9 candies. Those children began counting by 1s as they counted the pieces on the left and continued counting by 1s throughout. Someone might say you should always start with the 10s, but of course that isn't necessary at all. What is important is that children do not develop habits that are based on visual cues rather than our quantitative meaning. And that is the reason we include this task. In many traditional instructional materials, 10s are always presented on the left with the 1s on the right. When that is done consistently, some children will base their reasoning on what is on the left side of the picture and what is on the right side of the picture, rather than on the quantitative value of the various parts of the picture. So we include this example so that teachers understand that it is the quantity represented by the image shown and not its position in the picture that is important for children to attend to. After these introductory activities, which will be used only once, we encourage teachers to use tasks where the roles and pieces are not always placed together, and to always include 10 or more pieces. Here's an example. The number of candies in this picture is 31, and that is what children are expected to figure out. If a child says, I saw 2 rolls and 11 pieces, or maybe I saw 5 pieces, 2 rolls, and 6 more pieces, the teacher should ask, so how many candies is that? Do you have a way to figure that out? What do children do to figure this out? Lourdes might say, I saw 2 rolls, and that's 20, and then I counted the pieces, 21, 22, 23, 24, all the way up to 31. Notice several things about her solution. First, she distinguished between the 10s and 1s, the rolls and the pieces, and knew their quantitative value. Second, she didn't need to count the rolls by saying 10, 20. Rather, she said, I saw 2 rolls, and that's 20. Finally, she counted the pieces by 1s. Presumably, had there been only the 5 pieces on the left or only the 6 pieces on the right, but not both, she could have easily replied 25 candies or 26 candies. But the complexity of the picture requires her to deal with the 5 pieces and the 6 pieces, which exceed 10, and also with the 2 rolls. Her approach was to count on by 1s from 20 to figure out how many in all. As she explains her solution to the class, she will most likely indicate which pieces she counted first and which next. An important move at this point for the teacher is to ask, did anyone figure it out without counting? Danielle might say, I took 4 pieces from the left and put them together with the 6 pieces on the right to make another roll. Now I have 3 rolls, that's 30, and I have 1 piece left over, so it's 31. Notice how the language of the scenario has come into play in Danielle's solution. Also notice that Danielle did not say, I thought about packing up the candies in Mrs. Wright's shop to get another roll. She said, I made another roll. Well, she wasn't touching any physical materials. So what we know is that she made the roll in her mind. She was reconceptualizing 10 units of 1, 10 pieces, as 1 unit of 10, a roll. If we think back to the first 2 activities in this sequence, packing candies and circling candies, we can see the progression. In packing candies, children physically made a roll by combining 10 loose pieces of candy. The result is that 10 things became 1 thing. In the circling candies activity, children drew a loop around 10 candies in a picture to show what they would pack. And here we see Danielle making a roll entirely mentally. Now, I want to emphasize that not all children make this shift to making rolls mentally quickly. Some children will continue to use counting approaches for some time to figure out how many candies there are. But through discussions in which children give solutions like Danielle did, others begin to be able to do so as well. Let's take a look at a few other solutions students might give that are similar in nature to Danielle's solution. Max might say, I took 5 pieces from the 6 on the right and put them with a 5 on the left to get another roll. I had 3 rolls and 1 piece left over. That's 31. Samantha might say, I saw 5 pieces and 6 more pieces. That's 11 pieces. So I made another roll and I had 1 piece left over. Now I have 3 rolls and 1 piece. That's how I got 31. In each of the solutions given by Danielle, Max, and Samantha, the children thought about the pieces shown and reconceptualized them as a roll and 1 piece left over. Further, each of them said that they now had 3 rolls. In other words, they mentally transformed the picture that showed 2 rolls and 11 pieces into one with 3 rolls and 1 piece. They coordinated the units of 1 with the units of 10. Another way to say it is that they had a configuration of tens and ones, and they transformed it into a different configuration of tens and ones that represented the same quantity. Or yet another way to say it is that there is more than one way to use units of tens and units of ones to show a given quantity. And that is going to lead us to the next instructional activity, one we call the transformation activity. But before we discuss that activity, I want to make some important pragmatic suggestions about this Candy Flash activity. There are a number of important considerations the teacher must attend to when using Candy Flash. 1. The number of individual pieces should always be 10 or greater. The reason is that when there are fewer than 10 pieces, children can figure out the answer without having to reconceptualize a group of pieces as a roll and some pieces left over. Of course, they can always count on, as Lourdes did, but here students are encouraged to figure it out without counting. The purpose of this activity is to provide tasks where students encounter the need to mentally create another roll by packing up the pieces. 2, the individual pieces should be arranged in easily recognizable patterns. Otherwise, children will revert to counting them by ones, and counting defeats the purpose of this activity. Further, by using recognizable patterns, the teacher creates the opportunity for children to use what they know about combining small numbers, including number combinations that make 10. Think back to the solutions Danielle and Max gave. We also know that children that have not yet developed all of these number relationships continue to have opportunities to do so as they engage in this activity. Take a look at this picture, for example. Imagine if you saw this using the flashing approach. After easily seeing that there are 2 rolls, most of us would need to count the pieces to figure out how many there are. There are no obvious numerical groupings to use to figure out what to combine to get another roll. The third consideration is this. Since the crux of this activity relies on being able to mentally create another roll, the critical part of the task is that there are more than 10 pieces. The number of rolls in the initial configuration is not relevant, so it doesn't make the task more conceptually demanding to have 8 rolls rather than 3 rolls. In other words, just because a quantity is larger doesn't make it harder. For example, both pictures shown here have the same number of pieces shown in the same patterns. So the conceptual demands of creating another roll, which is the primary purpose of these tasks, are the same. Simply including more rolls, as in the first task, does not contribute to the purpose for which this task is designed. In other words, just making the quantity larger does not increase the learning opportunities the task provides. The fourth consideration is this. Children can become confused if we use the word candies to refer to both the total quantity and to the individual loose pieces of candy. For this reason, we suggest referring to the loose pieces of candy as pieces rather than as candies. So, for example, when the teacher asks how many candies does Mrs. Wright have, the children understand that she means the total quantity, not the individual pieces. The last consideration is this. Rather than create drawings to use for Candy Flash, teachers may wish to use Unifix cubes instead. Here you see the same example we showed earlier, but using Unifix cubes instead of a drawing. There are several advantages to using Unifix cubes, and at least one disadvantage. What are the advantages? One advantage is that it is very easy to create the tasks right at the moment. The teacher does not need to create drawings in advance. Of course, she can always draw them at the moment using a pen or marker. A second advantage is that children will easily relate these to the scenario because of their work with Unifix cubes in prior tasks. The third advantage is that as children explain how they combined pieces to create another roll, the teacher can move the pieces around to show that. For example, the teacher can demonstrate Danielle's solution by actually moving the pieces like this. A fourth advantage is that the children can see the individual pieces that are packed to create the roll. For those children that might still be working hard to think of a roll as a single thing that is made up of 10 pieces, this image might be useful. And this ability to see the individual pieces that comprise the roll is also a disadvantage in the following sense. With the individual pieces visible, a child can attempt to figure out the total quantity by counting everything by ones, including the ones that comprise the rolls. In my view, this disadvantage does not outweigh the advantages. Nevertheless, we chose to show all of the Candy Flash pictures we have used so far using drawings precisely because the 10 individual pieces that make up the roll are not visible. In the earliest stages of using this activity, children often have very specific ideas of exactly which pieces they moved in their mind. For example, if the teacher were to ask Danielle which of the 5 pieces she moved, she might say, "I moved all of them except the one in the middle." Another child that also thought of taking 4 of the 5 to combine with the 6 might say that he moved a different set of 4. Eventually, children will not be specific, or if the teacher asks, "Which ones did you move?" the child might answer, "It doesn't matter." We interpret a comment such as this as indicating an advance in the child's reasoning. Now the child is reasoning quantitatively. Take 4 from 5 to combine with 6 to get 10. The child is no longer thinking about packing up candies to make a roll. This concludes video segment 2. Video segment 3 includes a discussion of the transformation activity and also includes a timeline. A note to teachers: pages that can be used to introduce the Candy Flash activity and several examples are available on the website.